Also,
flat earthers told me
again,
that the sun sets because it gets far away. In this model, the sun is farther away in the summer or in the winter than it ever is in the summer. Therefore, it should never rise.
No, it would
again,
have rot. So
this
there's no
model.
difference between this model and the other model that you guys have. There's no difference.
No,
Dude,
this model.
honestly, bro, hold on. Concave makes more sense in this model, dude.
Oh, really? So
I'm throwing a bone to the concave.
Where's the model?
Again,
Where is it?
again, my problem with this model is that you're taking snapshots of different occurrences around the sphere, and then
Right.
you say
That's a
is not a
projection. That's
sphere.
not a snapshot. You're not. Hold on. That's not a snapshot. You need to You need to talk scientific. That's not a snapshot. That's the projection around two poles. You need to learn about cryptography and projections before you want to talk.
Okay.
About this. Sorry. Okay?
Okay.
That's not a snapshot. Okay. It's a projection. So AE is a projection. Hold on. AE is a projection. Is a projection around the North Pole. This is another projection. Mathematically, it's another projection. Okay. And look at it. This is how it works. It's around 2 points instead of 1 point. So what we did here,
Right.
we polarized,
Which makes it a sphere.
No, it's not a sphere. It's a plane. It's a plane.
If
Look at
something is a 3D shape,
You wanted to look
it's a
like a
3D
sphere. I
shape.
know because you're a globe head and you look at like a sphere. It's not a sphere. It's a plane. So literally, it's a plane. And those are tropics. And those
Okay,
why does it look spherical though? You have it like
It doesn't look
distorted.
spherical,
Like
bro.
the continents are distorted.
No, it's not distorted. Leave the continents. Like
It's worse than the AE map. Listen, bro, the AE map's already distorted. Gleason's map's already distorted towards the south. Australia is like all stretched out. It's not how Australia actually looks like in real life, dude. This map
is
looks
the
like
best layout.
even more distorted, dude.
It doesn't matter. We don't care about the shape of the land masses. Hold on. As long as it's plain, it's flat, and it's stationary and it's stable, it should be enough for a flat earther. This is based on my own experience with this last 10 years. You hold on. You can start yourself. You can start yourself with the size of the continents.
I'm not even sure it is stationary in your video.
Move on. Hold on. So if you're a flat earther, listen. As long as this map is flat and stationary, but the difference is that you have 2 centers on this map. And you literally, when you look at your sky, when you go on the equator, you can see that there's a northern pole and there's a southern pole. And the stars are going around them clockwise and counterclockwise. And this is how a torus field, hold on, bro, why you guys don't jump in, man. And this is how a torus field looks like. If you study enough about the toroidal fields, you're going to see the counter rotations. So your heart, look at your heart. You have atria, and you have your ventricles. Right, hold on. Your atria and your ventricles in your heart are making, like, bro, don't come in my speech. Please just mute your mic for 2 minutes. Thanks. So look at your heart, my brother. Your heart is a living being, right? It has 2 lobes. Each lobe is rotating.
Dude, you got listen, bro. You can't, dude. We were just talking about cosmology. Now you're talking about anatomy.
Reality.
All right, but
so
come on, man.
This is.
But dude,
okay. So
you need to.
The sky. Hold on. You're one of those flat earthers trying to away from the 24-hour sun experiment. I know about it. You cannot deny that experiment. That experiment was real. They really went there. I know the peoples. And before that experiment, we flat earthers we were warning all the flat earthers that they're gonna see it. Because the world is symmetrical.
Okay, how are you explaining on this map the sun taking a straight path when it's on the equator? It doesn't make a left or right turn. How do you know that? How do you know that? Everyone observes it to be a straight path. We would have to mark it out. The best bet flat earthers have at this point is adopting the Mercator map and going with Pac-Man Earth. That's the only hope you have.
No, the Pac-Man thing is something to just,
I actually agree with
your
that.
Mind. It's not real. It's not the Pac-Man.
Bro, this model necessitates the Pac-Man.
No. Just watch the video. This is how the analemma works out. You need to understand that there's a smooth transition. There's a transverse movement through the equinox. So in this transverse motion, it's going to be so smoothly. and so small that you would not notice it. So on the ground, as an observer who has a very small dome of vision, because you're a flat earther, you need to learn about your personal sphere. Your personal sphere would not allow you to see the whole thing in the big scale.
Is the
That's why
sun
we're-
physical? Is the sun
This is what-
is the sun a physical object? Is that what you're saying? The sun is a physical object taking a literal
No, it's the
path, and it
same
has an
thing that
actual
you had in your AE
location,
map,
or
bro.
is it an apparent?
It's the same thing that you had in your AE map. We just polarized the model, okay?
I
Well,
have
then
a
this is
question.
an AE map. You're giving an AE map because this is just a transfer of the coordinate system that's
stop
centered on the
playing
equator.
semantics with him. This is not to be equated to the Gleason map. The Gleason map, Antarctica is an
it's the
ice
same
wall
thing.
around the world.
It
Okay,
doesn't
don't
matter.
waste
It's
our
the same.
time,
Then what's
Torah.
around this world? What's around this world?
Don't waste our fucking
Torah.
time
What's
with your
around this
bullshit
world?
questions.
Answer it.
What- I
What's
don't- I don't-
around
what's at
this
the-
world?
Hey, fuck
What's at the
off. This is
extreme-
not your show, bud.
Yeah, you're done.
Bro, you need to relax.
So
dude.
you can
We're
ask
asking
Can I ask a
questions.
question?
We can't ask questions, though.
Only real flat earthers may speak. All you ice ringers, gate keepers, please be quiet. Let the real guy
I'm
speak.
not-
How about
I'm
you?
the
How about you
realist.
be quiet, dude? We're asking questions, dude. Can we not do that?
Lion, can I ask my question?
Yeah, go ahead, dude. Where everybody's allowed to ask questions. This
Lion,
guy's-
hold on.
this
Hold on.
guy's
Your
tweaking
boy
out.
Torah is gonna waste our fucking time and try to play semantics, trying to equate this map to the Gleason map. They're not equal.
All right, but he can do that, bro. He's allowed to voice his
Yes, but
opinion,
we
whether
can
you like it or not.
continue
You
with
can't
the
just...
idea.
Okay, but dude, there's a lot of people trying to ask this guy questions, French guy. You understand that, right? You can't be the only one asking questions. But yeah, go ahead.
Right,
but
but
then I got
was
my question next.
on your side. I
right,
was
so
on
you-
your side.
All right, go. All right, so go ask your question. I want to ask a
Yes.
question too.
So
and I'm
my
sure others-
question is,
Go ahead.
we have models, okay, to predict things and to answer stuff. So what I see in this map is that you're trying to find an answer for the 24-hour sun, which is fine and all, but it only answers this question. It doesn't answer seasons, it doesn't answer distances, it doesn't
does.
answer anything on the earth that we see in reality. So what's the point of this model?
Snooze. If you want to help these guys, compare this model to the Gleason model, to the ice ring around the world. That is the purpose of this model at the minimum, is to get these guys on this joke of a fucking map, gate kept and stuck, onto a better flat earth map that better represents things. Better. The key word is better. Better.
All right. Let me ask my question, dude. But for the record, I don't deny the 24-hour sun in Antarctica. You said I'm one of those flat earthers that denies the 24-hour sun. No, I'm not. You know, and I don't represent all flat earthers here. Maybe some don't believe the 24-hour sun. That's fine. That's on them. But I did want to ask you the same question that Torah asked. What's at the extremities of this model at the very end? What happens at the very end?
Okay, good question. Right. Okay, I'm glad that you're not one of those flat earthers who are denying the 24-hour sun, so that's a good thing. This model, it has another pole. So another pole, when we add another pole, we can define, or we can explain a lot of those things that we couldn't explain on the AE model. Like, for example, the Coriolis effects, right? The focal pendulum. On the AE map, like, but on the AE map, we didn't have any explanation for hurricanes, that why they move clockwise below the equator and above the equator counterclockwise. The Globers
That's
have
not
that.
true.
The Globers.
That's not true. We have that too.
Okay, cool.
And
Explain to
bipolar
me
electric
how.
field, they just found it.
Yeah, we've been
No,
talking
tell me
about it for
why
a
the
couple
focal
years now. It
pendulum-
has to do with toroidal physics, the same stuff that you're talking about, and it's
Yeah.
not exclusive to the dual pole model or the Glob model. You can have the toroidal physics on the AE map.
Yeah.
Go ahead.
The toroidal physics is in your heart. So look at how your heart works. It has a counter rotation, the same way that your sky has a counter rotation. So all the toroidal, so this is exactly why, because this is the weakness point of most of the flat earthers. They don't know how the toroidal field really works. The toroidal fields, it's not like that Polaris thing in the middle. You have a beautiful, I don't know, apple shape field around it. No, you have to study it in deeply. Like when you do that, you're gonna understand that every toroidal field will create counter rotations, and counter rotation will create a stable energy flow. Look your heart, the same way. If you look at your sky, you can see the counter rotation around 2 points. Now, this is because your reality is a duality. Look at your body. Your body looks symmetrical. You have
All right,
two
dude. All
eyes.
right, listen.
Yeah,
I'm
but
not,
what-
yo,
what-
listen, I'm not trying to. Hold on. I'm not trying to be rude, dude. But you're kind of deflecting. You're moving on to other topics, anatomy. I asked you specific
No,
questions.
this is
right?
schematics.
What's at
No,
the
no, hold on.
extremities? What's at the
This is
extremities
patterns.
of this
Hold on.
model?
I understand. No, I'm not moving anywhere. Hold on. Because you brought up the
I wanna get into it.
toroidal field. Hold on. When you're talking about torus field, you're talking about an apple. And an apple is a good representation of a toroidal field, right? Now, I want you to cut the apple vertically and horizontally. Now, and then look at the cross sections. Learn it, study about it, and you're gonna see the counter rotation. You're gonna see the two lobes. You're gonna see this golden spiral. You're gonna see the sun and the lima over it. And you're gonna see the tubal flowers.
Okay, get to the point,
So
dude. I asked you a question. You haven't answered it
okay,
yet.
so I'm
You're
not
still
jumping
deflecting.
anywhere. So when I'm talking about patterns here, when I'm talking about like symbols are so important. That's why the Masons are using it. Because they know that it, as above, so below, so without. Like these are the things. These are the law of
You're
correspondence.
still deflecting, dude. What happens? Hold on,
No,
dude. Hold
it's
on.
not.
Maybe I'll rephrase it. Bro. I'm gonna rephrase it because you're not answering it. Maybe you didn't understand my question. What happens when you go all the way to the edge and you keep going, right? Like dead reckoning, you just keep going straight.
AE mapper. Ask me those questions. That is only for this map. Look, this question that you're asking me is the same question that you can ask from an AE believer. So go ask it what happens in the ice wall. I don't know.
No, it's not the same. Okay, so in the AE map, if you keep going south, dead reckoning, you end up hitting in my model, in my opinion, based off theological justification, you end up hitting the ice wall. There's a firmament, the base of the firmament, the dome that's overhead. You end up hitting that. There's a physical barrier. Hold on, why are you talking over me, dude? Just wait a second. So in your model, all I'm wondering, bro, it's just an opinion. What's your opinion? If you keep going dead reckoning, doesn't matter which way, right? Any of the extremities, if you keep going, do you end up popping out on the other side like some Pac-Man shit or what?
No. Just throw it out away from your mind. Let's throw that Pac-Man thing out of you. We don't have that thing, okay? First of all.
So
second of all, bro.
So he's claiming there could be an ice wall out there as well.
It could be an ice wall.
Congrats.
Okay, that's all I wanted to hear, dude. All right, bro.
Bro, if it satisfies you, put your ice wall around it.
Okay,
that's it. I'm out, dude. I'm out. Somebody else can go. Go ahead.
Yeah, I got a question for you. My question is, why do you believe that these things are taking circular paths if you're invoking the dome of vision? Why wouldn't they all be linear and your dome of vision is actually causing them to be circular?
Exactly. Good question. Very good question. So your dome of vision will create everything to be like in a hemisphere. Right? For example, when you go in the flat desert at night, it appears that all the stars are touching the ground. But you know that as a globe or as a flat earth, it doesn't matter. You know that if you start moving toward that star, or let's say you're looking at Polaris and you start going toward Polaris, you know that Polaris is going to start coming over your head. Okay? And so you know that that's your personal sphere, and you know that it's your limitation, right? So that limitation doesn't allow you to see the whole spectrum of the sky, the whole stars, this planar thing that I'm talking about here, because your eyeballs are rounded. Yeah, well, hemisphere eyeballs. We need to, and this is just pretty much the thing that I always tell the flat.
Why are you drawing circles on your map then? Why are you drawing circles? Because all you need to do is change your map to the Mercator. All you have to do is change your map to the Mercator, make everything planar in the sky, and invoke your dome of vision for why it looks like.
The
even
star
though it
are
isn't.
circular. Listen. The star
because of your dome of vision, right?
No. The dome of vision will make the stars to come down to the ground and make that sphere around yourself. It doesn't keep them in the sky. You're just missing two things together.
How do you know that they're taking a circular path? How do you know they're taking a circular path? Like, for example, is the sun arcing or is it taking a linear path and setting as it gets further away?
It's a circular linear path like the stars, but in a different level.
Why would it be a circle? How do you know it's a circle?
It's just, bro, just look at the path. They're not perfect circles, but they're a curve. They go in this scroll. Some of them are golden. The sun is a golden spiral.
If I just place all of this on a Mercator map, I can make all of them just go in straight lines.
I don't know about your Mercado map, but bro, don't bring up the maps together. What are you doing this to your mind? Bro, leave the maps away. Look at the sky. The sky. Listen, the sky, as you said, you mentioned it. The dome of vision will create this dome thing around you, but you know it's not a dome. You know, because if you start going towards,
of course, I agree with you. I agree. I just don't get why. How are you jumping to the conclusion that these things are taking circular paths if everything is taking a linear path in order? When it hold on, real quick. Do you agree when it takes a linear path, it seems as if it took an arc over top of your head?
Okay, it's the star trails. Look at the star trails. Look at the video and look at the star trails.
Yeah,
How many times have I showed you? Those are circular.
This is the elephant in the room no one wants to address, dude.
It's you and him, bro. It's Gleason versus the dual pole.
I'm not a Gleason, bro. I'm telling you, I'm proposing Mercator. I'm straight up saying it's the Mercator map. Everything's taking a straight linear path, and you're stuck in an infinite loop.
His map is better than your Mercator map. His map, there is an actual
mine
northern.
Is more accurate.
Why don't you let me finish, bud? Why don't you let someone finish? You might learn something for once. His map has an actual northern point axis of rotation and a southern point axis of rotation. The Mercator, that point is a line at the top of the map.
Yep, yeah, and you have a dome of vision, which makes it look curved, yeah.
Okay, anyways, Kasra, as you were saying.
When it gets onto the equator, it takes a straight path,
you think
right?
that the dome of vision, so you think that the dome of vision creates an illusional, a holographic southern point?
Yes, what we call that. Yeah, we call it an abstract concept called the celestial sphere. It's an abstract concept. It doesn't actually exist.
Okay, so hold on. Let me just fix that in your brain. But listen carefully, and trust me. If you listen carefully, you're gonna get rid of this whole magical dome that you have in your mind. Okay, so Walter Bisler
I have a magical dome in my mind.
When you get close, hold on. When you get close to the edge of the AE map, your personal sphere will interfere with the dome, your dome that you have there, and it will create a southern sky holographic view over your.
I'm talking about the Mercator, not the AE map.
So even in even in your AE, you're saying that every individual
who goes down map, there, bro. It's a Mercator map. The one that was on the wall when you were in school.
So you're a flat earther. Okay, so you're a flat earther who believes that Mercator is the real map?
Yep, yeah.
Oh my God, never seen any. This is cool. This is really interesting. Really?
It's the only way you're going to be. Yeah, it's the only way you can explain all of the paths. Yeah, it's the only way you're going to be able to explain all the paths of the stars. Because when you see the sun rise and set, you say it takes a perfectly linear path. It's not actually rising and setting. It's due to perspective. So what you caused yourself to realize, what you just caused. Okay, it's your dome of vision, whatever. So what you caused yourself to understand at this point is all of the things in the sky are just as planar as the Earth.
You're the Mercator doesn't have the two axes of rotation though. That's the whole that's literally is the world. The two axes of everything from the stars all the way down to like the atmosphere and the jet streams. It's not just lights in the sky.
It has all of it. It has the two rotations. Yeah, if you're in the north,
I can hear your disingenuous smile. You're through the spirit, by the way, because
I'm not smiling.
Ladies and gentlemen, Kasra's dual pole model has an actual point for the axes of rotation, north and south. The Mercator doesn't have that. The Mercator certainly is subject to Pac-Manning because of
I'm fine with that. You saying we don't have the math for wormholes and infinite loops?
So his model works better with stars. That's for sure. His model during the equinoxes, the sun is literally making a rotation around those axes of rotation on your map. Anyways, continue on, Kasra. Pick your own battles. Continue.
Yeah, the equator. Everyone observes the sun going straight on the equinox, not curving.
Yeah, so on his map.
Has it curving?
Concave.
On the dual pole map, the sun on the equinox travels a straight path on the equator, one end to the other, a straight path.
I can't. Then it
It's
would
a
have to.
sphere.
Oh, it can't.
No, it can't because it would have
Well,
to take a circular path around something
So it
in
does
order to
that, Pac.
return back to his own
The line's
position.
gonna be pretty much straight. Okay, hold on. Let me just fix this in your mind. So you're saying that it has to take a circular path? No, it doesn't need to take a circular path. Look at the model in the equator. The tropics gonna be concentrated. They're gonna be tied in together, and they're gonna be more like a straight. So this is exactly how the magnetic field looks like. Everything kind of looks like this.
I like
just
to
look at a
share my-
magnetic bar and just hold on. Just draw a magnetic bar, look at the magnetic flux and draw the equidistant fields. It means the perpendicular lines over it. So you would get this two-pole flat Earth model. This is something that we have in electromagnetism. Just drawing the equipotential field over the magnetic field. So you have the magnetic field and you just draw the equipotentials. Equipotential fields are perpendicular to the magnetic field. And if you draw them, okay, and if you look at the center of this whole phenomena, the equipotential lines will be kind of a very more closer to each other in the middle. And this is exactly what we see in the sky. The star trails on the equator, they get tightened and they get closer to each other. And as they go toward the west, they diverge and they converge back
You're
again.
trying to
So this kind of
unify.
going
You're
back-
trying
hold
to
on, hold on.
unify the
Hold on,
micro to the macro. What is the reasoning behind unifying the micro to the macro? What's the argument for that?
It's so important. So if you look at gold, hold on. So what I said, it was like a human heart. It goes out, it comes back in. Even the tordial field, look at how the tordial field looks like. It pumps from the top, it sucks from the down, positive, negative, and it creates these counter rotations. You need to understand that we can see this.
You
in the
don't
fucking
see
sky.
it doing that. You don't get the
We
bird's
see it
eye
in the
view of
sky.
it doing
Come on,
that.
we are
You get
seeing
it
it.
from
Look.
your, hold on, real quick. You get that from your dome of perspective. You get all of those effects because you're invoking the dome of perspective. You don't have a bird's eye view to show that these things are actually rotating in that fashion.
Why does an
Right now, all you're doing.
Why does the airplane go straight? Answer this question. Why does the airplane go straight? And why does these satellites go
Airplanes
straight?
don't go straight. They go up, they level out, and then they go down. They take curved paths.
Okay, I don't know. Like I've never thought about this Mercator thing, that how it would have worked, but I know the magical dome that you would have think about is pretty much easy to be debunked, and that is by
I'm not
just
talking about
having
magical
100 people.
dome. I'm not talking about a magical dome.
said
I'm
that a
talking
personal
about your
sphere will
dome
create-
of perspective. Yeah, you have a personal sphere of
So you're
perspective.
saying that. Hold on.
around-
So you're saying that. So on your model, what you're saying that during the summer, during the southern summer solstice, which would be around 23 of September, the day that the Antarctic experiment had happened, you're saying that if you would have 100 people all along the coast of Antarctica, like let's say 100 kilometers away from each other, you would have said that like during that day, that the summer solstice over there, each individual would have experienced a different sun. Is that correct?
The sun is in a parent location, correct? I don't
Okay.
attribute.
Oh,
I know
okay,
that
hold on,
there
hold
is
on, hold on.
something
Okay,
physical
hold on.
causing
I
it,
know,
but yeah, where we see it is in an
Yes.
apparent location. Yeah,
Bro, that was a yes or no question. Okay, I just want
I can
want you to
expand
walk
on
with
it.
me.
I can
I want you
expand
to
on it.
walk with me, and I told you I'm going to fix this in your mind. So this is what you're saying. You're saying that if you would have 1,000 people, 1 million people, all across this, Antarctica, they're going to have their own dome of vision, their personal sphere, going to create a sudden point, a sudden star, a sudden system, a 24-hour sun. Well, now I'm going to give you this example. I'm going to tell you how you can debunk this in your model. Now, let's say all these 100 people or 1,000 people, whatever you have, they're standing over there, and you would be the last one who's going to be stand over all of them, like at the top of all of them. Like let's say you have a very good vantage point over all of them, and then what you're going to do is that you're going to ask them that, okay, during the summer solstice, you're going to wait till the summer solstice happens, and at the 12 of noon, you're going to call these people, and you're going to tell them to raise their hand and show the sun with their index finger. Okay. Now, on your model,
all
what's
these
going to happen
people,
here is
all
that
these
listen.
people are
Now,
below
hold on.
66.
Yeah, no, it doesn't matter. You're on 80 degrees, minus 80 degrees. So they were in at minus 80 degrees, right? So you got 100 people on the tropic of minus 80 degrees, right? So they're standing over there at 12 o'clock at noon, summer solstice over there. the top person up there, he's going to ask all these people to show the sun with their hand. Now, they're all going to raise their hand and going to show the sun. Now, on your model, what's going to happen here is that each individual will show different direction.
That's how it works right now. Have you ever stood next to someone and pointed at a star? Hold on. Have you ever stood next to someone and pointed at a star? Are you guys pointing in the same direction or not?
Okay, I know you're saying this is the case. I know. We know this. We know you're saying the magical don't create that. Why are you trying to expanding it? Okay, I'm saying no. Listen to what I'm trying to say after that. So you're on your model, each individual will point a different direction for the sun. That's a yes or no question. And you said yes. Okay. Now, I want you to understand this. In reality, this is not the case. The sun would be in a certain point in the sky. And now, you want to say, how do we know that? This is how the whole astronomical coordinate system throughout the thousands of years, either on the geocentric model or the heliocentric model, has been working. The sun is a fixed object in the sky, the same way that the southern point is a fixed object or fixed point in the sky.
Do you understand right now? If you take the geocentric model, everyone is pointing parallel to one another, right? You agree with that or not? Because that's what the geocentric model has. So exactly. No one is pointing the same direction. They're all pointing parallel to one another.
Exactly. Who said that? Exactly. Cool. That's the thing. And we know that that's not the case. We know that they're not going to do that. We know that every individual who's going to show the sun, he's going to show a certain point in this, a certain coordinates, a certain GP in the sky. You need to understand that GPs in your sky are not subjective. The personal sphere exists. It's a limitation of your sight. It doesn't allow you to see the whole thing. That's your personal sphere. We're not against it. That's
I agree. Okay. Now, and you agree the sun takes a planar path?
So did you fix that in your mind right now?
Yeah, but does the sun take a planar path or not?
Yeah.
And does it look like it arcs around you?
It goes around the southern point and the southern star. The southern Polaris.
No. Yeah, when you watch a sunrise to sunset, does it arc around you? But even though you know that it's traveling at a
we don't have first of all, flat earthers need to understand we don't have a sunrise or sunset. We have something called sun approaching and sun, I don't know, getting away.
Dude, you're getting into semantics, bro. Because if you point at the sun the entire day, what are you talking about? If you take your finger and point it at the sun the entire day, will your finger have made an arc around your body? Yes or no?
Well, that's your personal sphere. We spoke about this. What are you just repeating these things?
Okay, so now you would dude, the implications of that, if the sun is taking a planar...
of your personal sphere. Yeah. Okay, I got your point. The arc...
Dude, you gotta chill out a little bit. Give a little bit more room for him to speak, dude.
Yeah, it's high energy. We're enjoying this, you guys. Thank you.
Go ahead.
Yeah, I just want to tell you real quick. If the sun is taking a planar path and it looks like it is rising and setting around you, you would now explain all of the stars and everything. The reason that things rise and set is because they're further away and then they get closer to you. That would require everything in the sky to be on a planar level.
Exactly. Yeah, you just made a very good point, and this is the point that I always tell to flat earthers, that we don't know about the shape of our firmament. If you want to believe in firmament, it's okay. You can believe into it. But we don't know that really how it looks like. Just because the biblical texts, I don't know, ancient civilization, they've been talking about it. Well, they probably that would because the personal sphere that they weren't aware of about it. Well, we're aware about it right now. We know that how our perception works.
No, dude, we're not. No, we have lost the information and we're trying to regain it. When the creator created this place, he explained to man what's going on with it. Okay? And man, like a game of telephone, has perverted that information. And now you're trying to come to a conclusion that you're like, oh, you could believe in the firmament based on ancient texts or what. No, if the creator said it, it is. That's it. Period.
So you're religious? Okay, if you're religious, I don't mind. But scientifically, what I was trying to say here is that
it's not religious, bro. That's a relationship with the creator, bro.
Okay, so anyway, at the end of the day, I believe in the egg, the cosmic egg, and then like the apple thing that we are inside of this torreal field. The torreal field has to look like a sphere. Kind of a believe in that.
And that's just revelatory by what? What revealed that to you? Your own self? Oh yeah, so you're the arbiter of truth now?
Anyway, so as what I said, this is exactly a good point that flat earthers, they don't know about the shape of the firmament. If it appears to be like a dome, it's because of personal sphere. Probably you guys know about it, because we know no matter where we go, all the stars start to shifting up to our head. So, and we cannot, travel like farther, like somewhere that could hit somewhere or barrier
Kasra,
because of the treaties or whatever.
Yo,
So basically,
real quick,
this is a good point. Yeah, go on.
no, I'm curious. So, how's the sun completed circuit in your model?
The sun complete circuit, like daily circuit or a yearly circuit?
Like on the equinox.
Daily.
can I one
Yeah,
question?
on the equinox. On the equinox.
On the equinox.
The 24-hour,
listening.
48-hour period. Hold on. Just give me AJ. Just give me a second.
Yeah.
Go ahead. That's on
good
you.
question. So yeah, I told you. So daily orbits on the two-pole flat Earth model would have exactly looked like the AE model for the 6 month of a year. So if you want to know how it works, you have to just look at the AE model, how the sun will rotate around it. It's the same phenomena. The only difference would have been
but
on the equator and yeah. So your
But
crucial
how
days
is
would be
this-
one day, basically just one day.
On the equinox,
rest
though,
of the days
on the
are-
equinox, specifically on the
Okay,
equinox.
so on the equinox, it's better to watch the video because no matter how much I try to explain, it's not going to be
I
understandable.
posted the GIF.
So watch
You
the
could look at
video.
it.
All right. Go ahead.
Cool.
Go ahead, agent.
yeah, again, it seems like you describing some concave shape or a sphere inside the sphere. How is this different from having a concave Earth? Because I don't see the
Well,
difference right now.
Yeah, it's pretty close to the concave theory. I agree about it. And who knows? I'm not a concave earther yet, but I'm just working
you will
on it. I'm
be
just
very soon, dude. You will, because this is the concave Earth map, and that's why I'm
Whatever,
trying to show you. If you want to be a flat earther, the conclusion of flat Earth is what I'm telling you.
Yeah, also, you have an axis of rotation, for crying out loud. You actually describe the sphere in some way.
But it's interesting that the concave earther, they all know about this model. This is so like the first thing that really kind of gives me a push was this like all of them, they know about, like they pretty vigilant, they pretty educated, they're pretty intelligent.
Okay.
They knew about the
And
24-hour sun.
Check out your boy's third gift that he just posted. In the third gift, you literally watch the sun travel on the equator, and then it comes out towards you for some reason, and then just reappears on the other side.
If you tune into my live stream in that 3D model, I actually make the sun disappear so it doesn't confuse you so hard. Just look at the daylight patterns.
Why?
Okay, so
where is it going? When is the sun disappearing?
In this model, it'll go wherever it needs to go. What you need to look at.
People can just observe it and see the sun is out all the time.
Take a relaxation pill. This is the ultimate flat Earth model. Okay, that you will be convinced of shortly.
Can I ask? Wait. If you take two poles of a 3D shape, okay, and you stretch them around between something, okay, you make it a sphere. If you have two poles, okay, two centers, as you say, you just have a sphere. How can you not see that?
We do. It is a sphere,
flat.
but you're inside of it. You're inside of it.
So none of this is talking about flat Earth. So you will understand.
Yeah, some of the things
And
of
I
this
think
model were pretty much. It looks like Glob, the counter of the contra of the magnetic field and the equipotential fields. They exactly look like the Glob model. A lot of things, because a lot of things on the Glob model is correct, and we need to address that as a flat Earth world.
Unfortunately, you're invoking a perfect sphere, which the globe model got away from because they have anomalies, gravitational anomalies, magnetic field anomalies. So you would have to say this a perfect sphere. Why is the magnetic field not symmetrical?
Hey, there's various things to nitpick. Let's look at the glaring difference. Antarctica, the size of that puzzle piece of a continent, is more closer to the Glober's Antarctica, as opposed to the Gleason Antarctica, which is a big ass ice ring around the fucking world. There is no evidence of that. Completely fictional. And the Mercator ice ring, which is this strip of ice at the bottom, this linear strip of ice at the bottom of the world. The dual pole model of flat Earth is the ultimate flat Earth setup.
Well, unfortunately, when they go south, they hit an ice wall.
But is this not a flat Earth?
I don't know why that's a problem on the Mercator.
But again, I don't know, concave, why you call it a flat Earth model, because it's a clearly or a concave model or a globe.
I'm not interested in semantics.
Not in any way.
I don't find the same joy that you're currently experiencing with semantics.
What is a pole on the 3D shape?
No questions for you, bud.
Wait, do you understand that debates occur over semantics? Like that's the point of debate?
Discussion.
Do you understand that we know the measurable size of Antarctica, across it, around it, through it, diagonally, up above, from space? We know how big it is. We know the shape of it. And it's not an ice ring around the world, nor is it an ice strip at the bottom of the world from one end to the other.
How do you know that? Because if you have something that is infinitely looping, and when you exit out the south side, you pop up on the other south side, how would you ever know that?
Does Google Earth still have AI for the bottom of Antarctica? Is it still like animated?
Many reasons, but many reasons. Many of which I've already modeled and I have before me. Once you see the data, once you see the orbitals around the poles, once you see the jet streams around the poles, everything.
And I don't know. I feel embarrassed for you guys, dude. Like I'm embarrassed. I don't know why. Dude.
You feel embarrassment within yourself. That's your reality right now. Shout outs to Kasra for literally being the diamond in the haystack of a flat earther, thinking for himself, by himself, moving forward to look for a solution. Rather than repeating the same old biblical bullshit day after fucking day and getting nowhere. Thank you, Kasra, for your presence.
Mainstream BS though, like the mainstream narratives.
But how is this model any different?
Hold on, I couldn't hear Kayla. Did you guys hear her, or did you walk all over? Let her speak.
Yeah, I just said like purporting the mainstream narratives. Does that make you feel like exclusive? Or does it, do you feel like special? For like just believing what everybody else says?
Listen to this bad energy. These gate-kept individuals with no answers. No maps, no models, nothing that works.
Wait,
no 2 points of rotation. All they do is sit in rooms like this and ask people questions to try to bring them down.
Don't you think that like there should be models for the weathering systems or for like the...
Listen to her energy. Just trying to bring you down.
Can I say something?
Arrogance.
Can I say something? The truth is unfalsifiable, and we can falsify this map with the equinox right away.
Like a lot of things haven't been modeled for the globe either.
But wait.
Agent, hold on, dude. Give her some room. Everybody give her some room, dog. Like, what's going on?
I mean, I guess
she's responding. She is responding to a model that she didn't hear. Did you hear Kasra explaining his model, or you just want to deny him right away?
I don't have an issue with Cassandra's model. Like, I mean, I don't have an issue with him sharing that. I haven't really looked into all the pros and cons of each, but...
So why is the negativity?
What do you mean negativity? I'm in a great mood.
Bro, who cares, dude? Why are you guys trying to tone police all of a sudden?
I'm
No,
not.
that's not
negative.
Like,
tone
don't let
policing.
the
It's
mod,
exposing.
let the mods handle that. That's why we got mods.
It's not a
Stop
moderation
trying to be
issue.
mods, dude.
It's not a
Yeah, so why are you
moderation
tone
issue.
policing her, dude?
You better tone police yourself.
No, that's what I'm saying. Like, dude, I'm way more abrasive than she is. She's really coming in here really like polite and soft spoken. I don't know what your problem is.
They just want me to be all hyped
Not
up like
what-
Look
Look
at that map posted in chat.
Yes, I want you, Tyler, to still man his position.
in terms of
Can
what?
you?
Still in his position on what
About
topic?
the two-pole model. I want you to describe the two-pole model right now.
Cassandra's system, yeah. Well, they're saying basically the stars would be rotating in two different directions. The sun would be going in two different directions. This would explain a 24-hour sun. And Antarctica would be like an island on like near the southern hemisphere, and there would be like a dipole system, kind of like you see with the magnets in water, like where it's two different types of rotation going each different direction. And yeah, I know about it. I've heard about it the other day.
So where is the flat part in what you said? Because it sounds to me like you described the globe.
Yeah, so instead of there being like a northern and southern hemisphere, instead of those being like on each side of a globe, on each side of a sphere, basically the same phenomena would just be in the northern and southern hemispheres of the flat Earth model.
Exactly.
But how?
Thank you.
How can one place see at the same time different directions of rotation of the stars?
Yeah, the same way if you have let me see how to, like, what about like a star projector on your ceiling basically, and you have two different poles, one rotating clockwise and counterclockwise. Just like in the magnetohydrodynamics, you have basically water rotating in two different poles, two different directions based on the location.
Didn't you cover the projection thing in like, I'm sure I heard someone even giving this example. You are not going over the stars. You're still under the stars. You cannot be under the stars and see different things happening over your head. Or you don't understand what we are talking about, the rotation of the stars.
The rotation of the stars would not change. Above the equator, it would always go counterclockwise, and below the equator or below the celestial equator, it will always go clockwise. So no matter where you go, you're gonna always see this phenomenon.
Nice.
So
nice.
she said the
what
same
is
thing. She said the same
What
thing.
is the equator? What is the equator on your flat plane?
There wouldn't be an equator of sorts in the way that you're thinking about it. It would just be where those rotations
Exactly. So you need to give me the alternative.
So do you see whenever you're looking at the equator into the stars in the sky and how they move? Basically, like and they begin to start bending. So do you see whenever? So instead of saying that that's just basically like the stars will be moving straight across, it's actually moving in different directions.
Why is the stars suddenly bending to your will?
Well, that's what we see in the sky. If you look at star trails to the equator, have you seen them?
Wait, so if I'm in the north hemisphere and I see one set of system of the stars, and then I travel to the south hemisphere and I see a different system of the stars, so how does it work? Leave alone the directions. I just see another stars.
So Occam's razor, I'm just like steel manning the dipole, right?
So, Occam's razor. No, you don't know Occam's razor.
Okay, not Occam's razor. All right. So if that's what you see the stars doing, then we're gonna assume that that's what the stars are doing. They're just rotating in different directions.
Yes. Can I clarify Occam's razor and why I don't like when
the one with the least amount
anyone mentions it? No. It is not correct. It is the least amount of assumptions that explains the phenomenon.
That's exactly what I said.
It means between two. No. You're leaving apart the important part, which is explaining the actual thing. Okay? Because you can have many explanations. But if you have two explanations that fit, and you usually, as flat earthers, provide the explanation that doesn't fit it, so it's not Occam's razor. Occam's razor means you have two fitting explanations to the phenomenon. And what you're suggesting doesn't explain what I'm saying. Existence of an object in the sky, which is different from an object in the sky in the bottom half of the sphere, doesn't explained by magic projections. Especially because we can follow all the movement of the different stars and the constellations and predict where they will be in each given moment. And therefore, I cannot understand how we can stand on a flat plane and see different things at the same time.
Yeah, so I mean, in order to see which model is correct, first of all, you need to see, which Earth, like, can we prove the Earth is curving, and can we prove the Earth is moving?
No, we were just comparing two flat Earth models. It's not curving, nor is it moving.
Yeah, I mean, I don't necessarily have an issue with the model.
In the two-pole model, the Earth is not moving?
In the, I mean, no, it's flat Earth, it's level, it's stationary, so no.
Because I saw in his video, in the example which he gave, like a Torah radio field, it seems to move. Because in his model, the sun and the stars are fixed. Okay?
I mean, I start with the most consequential things first. Like, the most consequential thing, just looking at it, is the size of the continents, is the physical arrangement of where things are at. That's the most consequential thing first. Antarctica is no longer like this, but it is now like that. And everything from Antarctica, the oceans, bordering it, all those change too. That's the most consequential things. And then it goes down from there. So
I agree, but yet in your concave, even something is supposed to move. Like the sun and the moon are moving, or the Earth is moving. Something is moving. Because we see that. You cannot say nothing is moving.
It's called the cosmos. It's called the cosmos flow, the cosmic flow. That is moving.
Can you elaborate?
Yeah, it causes. So basically, you have two celestial inertia frame, or two celestial inertia sphere, or two inertia polar vortexes. One on south, one on north. One goes clockwise, the other one goes counterclockwise. Consequently, things below it would have moved to the other direction. For example, the sky of the northern hemisphere would have moved counterclockwise, but the focal pendulum moves clockwise, and vice versa. Now, why this is the case? It's because, for example, if you sit in a car, the car goes forward, you're going to go backward a bit. You're going to hit the seat and be pushed to the seat. This car is going forward. So that's the type of a bias that these two polar vortexes are creating in our reality. And it's causing this Coriolis effect to happen. So basically, the sky is pretty much dynamic, and the Earth is just a flat, stationary, stable plane. About the edges, we don't know. I don't know. Like, well, that's not the thing that I have ever covered. But the sky is.
I think you need to model it actually and see what you're talking about, because it's like when you invoke something like vortex or any other addition to what is observed, you need to stand behind why does it happen and why do we measure and observe different things. And you need to answer stuff like distances, seasons.
Yeah, I mean, he just said something about you go back in your seat. What is that? Why things fall to your Earth? God, I don't know his name. I don't know him. I know I talked to you on Geos, and I said I didn't. He might make much sense to me. Why do things fall to your Earth?
Yeah.
What? Is what?
So what's your question?
Why do things fall to your Earth?
Because of gravity.
Okay, what's your gravity then?
How does gravity work?
It's a bias toward the ground.
Yeah, okay.
I don't want to invoke buoyancy or anything right now, because I know probably heard a lot about it. But gravity is something that nobody knows what is it. It's still a theory. It's still something. It's a riddle, basically.
No, that's fine. That's fine. Wait a minute. You can call it downity. I don't care what you call it. I don't care. I just want to know why you think things fall to the Earth. That's all.
To me,
there's a constant, right? There's a constant there, right?
Yeah.
Do you think that too?
We can talk about it. I don't mind. So basically, you're talking about the acceleration that we have in our nature, which is about 9.8 meters per square second. So
yes.
That's something that we have. And that's something that we can detect, we can measure, and we can build things with it. We can engineerize it. We can do whatever we want with it. So that's the number that we have in our nature, like the other constants. So
right.
So what's your question? So what
is asking you, why do you have downward bias on a flat plane, and why does it change with different heights?
Okay, so even this question would be valid for an AE believer. I think most of the flat earthers are right now probably AE believer. They can answer this. Like, I have my own answers. My answers are a little bit, probably.
I didn't ask them. I asked you.
I'm not gonna. So my theory about gravity is, as I said, is something that's a little bit kind of complicated. So I'd rather not to talk about it here.
Well, I mean, I mean, that's your choice. You can disengage. You can do whatever you want, dude. But I mean, we've got all night. I mean, we've heard it all pretty much. So don't worry. I mean, I'm sure it won't be too complicated.
Yo, if you check my stream, I have a 3D model of the dual pole next to the AE map. I've got satellites, orbitals, I've got clouds, and daylight patterns, and you can just look at them side by side, see some difference and some implications. If one world were to be set up this way, you just look at it and see it as it is.
Which is which?
The one on the left is the AE map, the Gleason map. The one on the right is the dual pole setup. Oh, it crashed. Hold on.
Word.
But anyway, Kasra, even if you don't have the solution right now, you still need to fit questions like, why do I have 9.81 in a certain place on Earth? Stuff like that.
It's not certain place. I think everywhere is almost 9.8. I haven't measured by myself, but I pretty much think this is a good demonstration that we have.
It depends on the height. It depends on the height.
Well, it varies a little bit, very little bit. Like in the ISS,
it varies, but it varies.
For example, they're saying that in
the point
ISS,
here,
it keeps crashing.
The point here, it is not constant, and it changes over the planet. So you need to answer that, because no matter what you're invoking right now, you need to answer the stuff that we already know. Like I told you, you will need to show seasons and so on. Sunset. I don't know what sunset is in your model, but
it's the same thing. It's not different than the AE map. Some of the things on the AE map is still cool and it works fine, especially in the northern part of the world. It looks good. So you can ask the AE about how.
This is just another coordinate system. It's just the same AE map, just transferred with it centered on the equator rather than on the North Pole. But it just doesn't fix the problem of the sun on the equinox.
No, the only thing that he is fixing is the sun, the 24-hour sun, by creating two poles.
Rotation, basically. On the AE map, the AE map wasn't polarized. It was a monopole map, and we couldn't explain a lot of things on it. For example, the focal pendulum couldn't be explainable on it, right? These are the things
it can, dude. It can. Every rotation has a counter rotation. That's like when you drive a boat through water. The water is moving in one direction in the wake and another direction on the outside of the wake.
The main problem with the main problem around. I'm sorry. Go ahead, French Cat.
Yeah, the problem with the counter rotation on the AE map is that there isn't a single counter rotation on the AE map. There's multiple, because there's multiple continents that are south, and each one of them looking south see the same rotation. So you either have an infinite amount of rotations or something's wrong.
Yeah, that's the main problem with the AE map is the counter rotation in the south with the sun and the stars. That's basically it.
And on the ground, also on the ground. So they might be able to explain some of the things with their magical dome. And this is the thing that I'm telling you, flat earthers right now, the ones that will believe in this AE. You might be able to explain some of the things with your personal sphere. We can say that, yeah, our personal sphere creates that sun world and whatever you believe into it, but it doesn't fix things on the ground. And that should ring something in your head.
You should track the path of the sun on the ground during the equinox and throw this away too.
I know what's going to happen to the sun. The sun would go around Antarctica. We have seen it in 23rd of September doing the Antarctica experiment. We've seen those people watch the sun. They observe the whole cycle of the day. They watched it. They've seen that the sun is going around a fixed point in the sky. And correspondingly a fixed point on the ground. They have seen that. They take a video for you people to understand there's a fixed point that sun will go around it. So I know.
Yeah, and on the equinox, it's a straight line, dude.
No, it's not a straight line. You have that in your line because you have to watch the video from minute 6 to 7.
Everyone in this room, what do we observe on the equinox? Does the sun travel in a straight line or does it take a curved path?
Right now, as I perceive it, it's a straight line, dude. With sundials. We all the SADOC calendar people all track the straight line equinox.
So here's my words. So as I said, the model doesn't have equator. The equator is an imaginary line. As long as you would be perpendicular to any of these two poles, you're going to circumnavigate. If you're not going to circumnavigate, you're going to hit the walls the same way that you hit the wall at the AE. Now, if you want to know about the equinox, how the sun moves from from north to south, and south to north, well, you can check that
from east to west on the equinox, bro. In a straight line.
From the east to west on the equinox, let's say on the 20th of March, right? That's your spring equinox. So the sun would have started making big circles on the south pole, and eventually.
No, it doesn't. It makes a straight line.
No, I'm telling you, it makes a circle because the star trail makes a little circle. That's a curvature of space time around.
Well, that might just be what you're perceiving. But you just said, let's measure the ground. So this is what I want you to do. The next equinox, go and follow the sun and put stakes in the ground and show me a big circle on the ground.
Do you agree that it would make a circle around the southern pole during the summer solstice?
No, I don't.
Okay, so that's your problem. You don't believe that the sun goes down there and making a rotation around the southern pole?
I'm perfectly fine with just sticking to my original argument. So far, you have not refuted the Mercator map.
So you're the Mercator dude. Yeah. I don't know.
Mercator doesn't solve any issues compared to the other one. It's
all of them.
You're losing that whole dual pole, dual counter rotation geometry. That self-similarity idea thing.
The celestial sphere is an apparent effect of how we observe the universe. So it turns into a sphere, but there's no evidence for the sun being on a spherical path or a curving path. Everyone says it's on a planar path. That's why it rises and sets as it gets closer to you on that planar path. So I'm just saying everything in the sky is moving planar and linear to the Earth. And it's infinitely looping. So it would be, if you were to conceptualize this into a model, you would draw a sphere.
That's just so backwards to me. So your reasoning for why your ground, your position of the continents, the shape, the size, the shape of the continents, as we know them and can visually see them with our equipment, is because of what's going on in the sky. I've heard that before in these circles.
No. What's wrong with the Mercator map? What do you have issue with it?
The dual pole is superior.
No, it doesn't matter. You have those dual poles as long as everything is
listen, I'm in the knowing. I'm in the knowing of this. I'm not debating you. I'm not asking you. I'm telling you. This is my opinion. You stay on the Mercator. I'm not asking you anything. I'm not begging you anything.
And I'm telling you, I can falsify your opinion, and you can't falsify mine.
Okay, well,
I believe I hold an unfalsifiable position.
You hold that. I've got visual model in front of me that shows me the dual pole model makes more sense.
Explain the straightness of the sun on the.
Hey, your aurora borealis goes all the way across the world in a linear thing. That's interesting. We could see from higher up that it curves. Your jet streams just travel straight all across the world. That's interesting. Yeah, we know that. Yeah. We know that they travel circular. We know that there's actually counter rotation. That's interesting.
How do you know that? How do you know that? If it's on a Mercator and it's infinitely looping, that's what you would draw it as, is a circle, right? An infinite loop is a circle.
Balloon winners, if you look at the balloon winners, you can see the hurricanes, you can see that they're a golden spiral. And golden spiral is something that has been repeatedly, you can see it everywhere in the nature. It's one of the patterns that has been, it's a divine pattern. So of course the hurricane is going to look spiral the same way that your sky looks spiral. They can keep saying that the personal sphere creates that, but it doesn't make sense for me. It doesn't make sense. And by the way, you say that we didn't falsify.
It does make sense to you. It does make sense to you because you agree this right looks like it takes a circular path while at the same time saying it takes.
Let him have it, Kasra. Let him have it.
But he's right about the planar thing that you say that it appears that everything looks planar. But I agree with what you were saying. But if you remember, I told you if you would have those 100 peoples over there, and they're gonna. You remember that we falsify your model, that it's impossible to have hundreds of subjective suns and subjective.
No, it's not.
Southern world. So you still think that they all have to have
infinite? No, everyone is seeing the sun in an apparent location. If you got two people next to each other, they're going to be pointing pretty close to the same spot.
What about the people? What about the people 100 miles away?
Yeah, it's going to be the sun is going to be taking the path, and it's going to be getting closer to them. So the people that are right underneath the sun. Do you agree? The people that are right underneath the sun are going to point up, and then the people that are watching it rise are going to point horizontally, right?
Yes, exactly. They're going to point like that. They're going to point a fixed point in the sky. The same way that you're going to point the sun as fixed point during the summer solstice, which would be our summer solstice, which goes around the Arctic. Now, here's the interesting thing. You flat earthers, some of you guys believe that, okay, the sun that we see on the summer solstice that goes around the Arctic, that's the real sun. That's not due to our personal sphere. But the sun that we see in the southern world.
I don't say that.
So you even say that that's a subjective sun. Now, you need to understand that.
Dude, everything in the sky is apparent. There is a physical location to it, but we don't see it in its actual physical location.
Well, that's your personal sphere. We know about it, that your personal sphere doesn't allow you to see like 1,000 miles away. We know about it, but the thing is that the spiral thing that it's happening up there, and also
he doesn't know anything about that. He doesn't know anything about that. That's why he's clinging to Mercator.
No, I'm saying it's infinitely looping. It's perfectly fine on the Mercator. If you
guess what?
North and the Mercator, you would.
The Mercator, forget axes of rotation. We don't even need any of them. North, what's that? South, what's that?
They're arbitrary points placed on a map. Why don't you have an east and west pole?
They're not arbitrary, bro.
Bro, Kasra, listen to this. Listen to this guy's energy. He's not even being honest with himself. Like I said, let him have it.
Have you taken the compass and got to the North Pole yet?
I just posted a video of a 3D model of the dual pole map showing the stars counter-rotating both north and south with the sun at the same time. I'd love to see that with your Mercator model. We'll wait, and then we'll compare and actually see which one makes more sense. We'll place random people in different places, have them point in different areas, and then we'll see.
Your model is falsified on the equinox, bro.
The equinox, the sun travels in a straight line over the equator. One way to the other.
And then how does it get to the other side?
And then it appears on the other side just like yours does.
Okay, cool. So you have Pac-Man Earth as well. And you're sitting here trying to make me look like a fool.
But you're Mercator, bud. Your Antarctica is a strip on the bottom of the world. You think that's how it is? And you know what, ladies and gentlemen, we are making progress. The community is moving away from the ice ring model, which is the most laughable of them all. I do agree that the Mercator model is better than the ice ring model. So
you can. It's just a transfer of the coordinate system. They're all depicting the same infinitely looping coordinate system.
Sooner or later, Torah, you'll realize.
Okay, tell me what a 4D manifold. Tell me, Gatebreaker. Tell me what a 4D manifold is.
No, I'm not going to tell you anything
in your own words.
From me.
Yeah, you don't know about manifolds, bro.
No, only you do, bud.
No, because I actually tried to follow this line of thinking to its conclusion, and this is the conclusion. Okay, when you're saying you followed it to its conclusion and you came to the conclusion of concave Earth, yet the water ain't curving, you're in a problem here.
Looks like we've lost Lion Lady or Torah, ladies and gentlemen. He thinks we're talking about we have not discussed that a single time today.
I'm still here. I'm laughing right now.
Yeah. Sorry for mentioning
you guys are hilarious. No, but with the manifold stuff, if you guys look even right now with relativity, the geometry of space-time, there's a few leading ideas, and they talk about the manifold shape of space-time. You guys ever heard of it? Because space-time has a geometry, and they're debating what's causing or what type of geometry it is. There's even the golden shofar model of space-time. There's the manifold where it's like it bends in on itself.
Just like you guys claim, the toroidal field, which continually loops onto itself. What's the thing inside the toroid? What's that called? Hyperboloid, yeah. So, right, you have a hyperboloid and the toroid, and they're looping infinitely onto each other.
There is no toroid or hyperboloid in the Mercator model. There's just a film strip going across the screen, and that's just how the world works.
It doesn't matter. It's just a version of a manifold, is all it is. It's infinitely looping.
It's a flat a sine wave film strip. No toroids, no counter rotations. We're just
don't worry. I'll let you guys
film
catch
strip
up.
reality with Pac-Manning. I'm not strawmanning it. That's actually what it is. So it is what it is.
Yeah, we have all the math for wormholes. We have all the math for wormholes. It's fine.
So where's your toroidal field on your Mercato, bro? Literally, it's
a manifold, bro. It doesn't have to be. It doesn't have to be in the shape of a toroid. It's just a manifold. You're conflating the idea that the micro has to match the macro, and you don't even have a reason for that.
Well, we can see that repeatedly. Like you can see small scales of something that is going to be repeated in the bigger scale. For
in
example,
the bigger scale of the sky. Something you can't empirically test.
Let me give you an example. Look at the arms of the galaxies. Have you ever seen them? Look at some of these golden spirals that you see.
Yes, we've seen all the Fibonacci patterns.
So now look at the sculpt. Look at the vertex. Look at the vertex on your skull.
Yeah, we're not denying that. I see the golden ratio in our bodies, right? The what Da Vinci called the human body, the Andy knows.
Exactly. So yeah, you can look at it that way. You can say that, okay, the Earth has to kind of resemble a toroidal field. And I know the flat earthers believe that the Earth is a living being, so why not?
It's a sort of a manifold. It's a sort of a manifold, right? A torus is a manifold, right?
Okay, so how does it look like? Because yours is just a flat plane, like
What do you mean? How did it look like? I can't tell anyone. How does it look like, bro?
It's a Euclidean rectangular, basically.
Manifolds? Are they Euclidean? No. A toroid is Euclidean.
But yours is Euclidean. The Mercato is a Euclidean map.
What are you talking about, dude? Like the parallel postulate holds on it? You're saying so the parallel postulate holds, right? Yeah, so parallel lines on the Earth, even though they look to be converging, are actually not, right?
What?
That's the difference between Euclidean and non-Euclidean is the parallel postulate.
Don't intersect, but the apparent positions of the luminaries aren't Euclidean. You're not dealing with geometric positions. They actually move.
Yeah, I agree with that. For sky, you do have the manifold, and pretty much we have that on the two-pole. That the manifold that is around these vortexes that we see right now, those two polar vortexes. But on the ground, it looks like a Euclidean flat plane. Oh yes, it looks like that. But the Mercato model, here's the thing. Let me tell you about the map. And you got to understand there's a difference between a map and a model. Flat Earth map is different than flat Earth model. When you're talking about a map, you're talking about cartography and surveying. How continents looks like, how the flat. Well, that's the mapping thing, right? And that's it. But when you're talking about
dude, look at your picture, Kasra. Look at your picture, bro. Look at the line for the equator, bro.
Hold on. So your spectrum is just bounded to the planar's plane, to this physical plane, to how it looks like, and that's it. But when we're talking about model, we're talking about the sky, the physics of everything, basically. And of course, you have this planar physical stationary plane over there.
Just to be clear, they don't even have a map because they don't have a scale, right? So when they draw the continents, it doesn't mean anything because they don't even show the relative sizes. So they don't even have that.
You can have that. It doesn't matter. It really doesn't matter. As long as it's flat and stationary, you don't need to bother yourself anymore. And this is the point that I'm telling you. Don't bother yourself with these type of things that how the contest looks like, how the flight path going to work out. Look, it's completely not. It's not vital. That would be exactly.
You don't need that for the model, right?
You don't need that for the model.
What are you talking about, bro? You don't need to. You don't need to be able to map out flight paths on your model.
No.
As a flat Earth, you need the continents.
Yeah, but admittedly, even in your maps, the continents aren't the scale, dude. It's not the scale in any of those maps.
On the globe?
Yeah.
It's not even a scale on the Mercator. You guys didn't even ask me how I fixed that problem.
You don't understand. To scale and a scale are two different things. I know you know this, and you're just going to pretend like they aren't.
They're not two. I said they're not two scale. Yeah, that's what I said.
Yeah, but you don't even have a scale on any of your projections.
Okay.
Okay, so you don't even have that. You don't even have a representation.
Well, yeah, but nobody's actually surveyed the entire Earth from a single reference point.
Okay, so that's not what a scale is, though.
Well, it's going to be difficult with time dilation and length contraction to even measure any of these things.
Are you talking about Einstein's theory of special relativity? That talks about when you go near the speed of light. What are you even talking about? How? Oh my God, they're actually just liars. It's so insane, bro. That is such a.
How do you know what speed you're traveling at right now?
Do you think we're traveling close to the speed of light, buddy?
How do you know? How do you know what is it? Is an all motion relative?
Because there's no time dilation or length contraction. That's how we know we're not traveling close to the speed of light.
How do you know that when all your maps are all messed up?
Yeah, that's how
you're not even talking about a scale anymore. I know you really don't want to talk about a scale, but you don't have that.
It's not that the thing is, it's not about not having time dilation. You don't have time dilation no matter what you're doing. The reason it's not that we're not traveling at the speed of light. All it takes for us to be traveling at the speed of light is somebody seeing us travel at the speed of light, and that would mean that they're traveling at the speed of light relative to
travel
us.
at the speed of light. That's not a thing.
Well, not at the speed. I mean the point is 0.9 c. Then make it. If somebody is traveling, if we see somebody traveling at 0.9 c, then they see us traveling at 0.9 c, and nobody can say which one is actually doing it because there's no such thing as absolute velocity.
Do we see anything traveling at that
But
speed?
just to be clear, he won't acknowledge that. We brought this up.
Do we see anything traveling near the speed of light?
Do we? You really brought this up because you won't acknowledge the scale thing. Do you want to acknowledge the scale thing or not?
Dude, he was messing around. Obviously, we're not traveling at the speed of light when we're in a plane.
Okay. Yeah. So do you acknowledge the scale thing or not? None of your projections have a scale on them for a reason. Are we gonna acknowledge that? Are we gonna acknowledge that fact?
Hold on, the other guy's trying to get in. He's not gonna stop, dude. Let the other guy in.
Yeah, but are we gonna acknowledge the fact that none of your projections have a scale?
Bro, I already told you, dude. None of the maps are to scale.
That's not what I said. And you know that's not what I said. Now you're just being dishonest. I said, are you gonna acknowledge the fact that none of your projections have a scale?
No, they do have scales.
What scale are you using? What scale are you using, Tuak?
Okay, so you guys don't know what a scale is?
They do have, the AE map has a scale at the very bottom, dude. What are you talking about? It's just not accurate.
Yeah, send it.
No, just tell me what is your scale you're going off, like 1 degree per 69 miles?
On the scale that of the
do you not know what a scale is?
Well, I'd love to see the measurement from 89 to 90 then.
Okay, so if you don't know what a scale is, that's not my problem. But it still stands that none of your maps have a scale. So if you want to send
1 degree per 69 miles isn't a scale.
If you want to send a flat Earth map that has a scale on it, please send it.
Yeah, the AE map has one at the bottom.
Yeah, send it.
The Mercator map.
Yeah, send it. Send it.
And showing the scale of where Antarctica is shows that it's just a point. It's 0 kilometers.
Yeah, let's see that scale. Let's see the scale. Go ahead, send it. Send that map. Gonna send it? Flat Earth map with the scale?
Bro, I'm driving. I can't send you the AE map. It has it on the bottom. I promise you. The AE map has a scale on the
You
bottom.
really shouldn't be talking on the Discord.
Why not?
At least the map doesn't have a scale.
Because you get really upset and it's a really bad idea to drive all emotional.
Dude, I'm chilling. Don't worry about me, bro.
Okay, let's see if you're gonna be chilling for that much longer.
You're retarded.
See,
are you just trying to trigger people to now? Because the way you're trying to because the way you're trying to like interact isn't a triggering matter. Okay, all maps have scales on them.
Not my problem.
No. Well, you're doing it intentionally, obviously, dude.
If you think that's the case, it's still a you problem, not a me problem.
I can tell. I can show you what your intentions are.
Okay, if you think my intentions are to trigger you, that's a you problem, not a me problem.
Yeah, continually interrupting when people are talking. That's one of the ways we can tell what your intentions are.
You getting triggered, that was still a you problem and not a me problem.
Okay, I know you are, but what am I? That's your argument. Okay, so when you ask for a map with a scale, what map doesn't have one?
No,
I asked for a flat Earth. I asked for a flat
Earth
Earth map. Yeah, so I asked for a flat Earth map, right? One that you think represents the true flat Earth that we live on, with a scale on it. I would like to see that.
Yeah, that can't happen.
What's wrong with the Mercator map?
I want to see it. Just send it.
The Mercator map? You want me to send it to you? I don't understand.
Just send a map that you think represents the flat Earth with a scale on it. That's all I want.
So let me just tell you this way. Let me just help you with this one. Okay, look at the two-pole flat Earth. This is pretty much the same thing that I told to Matthew the other day in the other room. That he was I think he was a pilot. I don't know where he was, but he had some data. He had some data from I don't know from where, but he knew about the flights and he was saying that he was saying that basically Sydney San Diego doesn't make sense on the AE and blah blah blah. So what I told him about this two-pole flat Earth model was I told him to check out the flights, especially the southern flights, and see whether they make sense or not. And what I told him was that since this two-pole flat Earth model is not so, pretty much, it's not, emphasized on the shape of the land masses. And as I said, it's not pretty much accurate about the land masses. You can take off any land and change it wherever you want and find the best or the closest solution to the flight path that you have. So that was my advice to that person. And I told him that the two-pole flat Earth model is going to make more sense compared to the AE because the continents, especially the South America, Australia, and South Africa, they're going to be more closer to each other. So if you look at the two-pole flat Earth model, you're going to see that these three continents, exactly like the Glob model, going to be more closer to each other. So those southern flights going to make more sense on this model. Now, if it doesn't really match exactly the same, like the hours and all that, the duration, well, as I said, it's arbitrary. Just change wherever you want. You can move on Australia a little bit to the west. You can move Antarctica to the east, and you can just change it the way that it matches your reality. That's it. So as I said in the first place, we're not focusing on the land masses. As long as it's flat and stationary, you should concede here and should move on. Now, if you want to do a cartography, well, you can just do it. That would be good. But it doesn't have any impact.
All right, dude, bro, listen, you got to wrap it up. You can't just monologue for 2 minutes.
I told you to get emotional. Chill out, bro. It's not that deep, bro.
Dude, I'm not getting emotional.
So why are you yelling?
I'm not yelling, dude. Why are you tone policing me?
Do I have to warn you again to cut out your tactics?
He literally just did the exact same thing to the other dude.
Bro, don't do it.
I'll just tell him to wrap it up, dude. He's repeating himself. I'm letting other people go, dude. That's all. Damn, man.
Yo, let's not use moderation as a means of like, you better not mess with me or I'll moderate you. Like, if we're gonna engage with
Who's
energy
doing
with
that,
someone,
bro? Who's doing that?
if we're gonna engage with the energy of someone and play ball, like don't get mad if they hit you in the same way that you're.
Are you referring to me?
No, I'm just speaking in general.
I'm not complaining about anybody's energy, bro. You guys are the only ones bitching about. First, you're bitching about Taylor's energy. Now you're bitching about my energy. How about you worry about yourself?
Yo, we had a great conversation bringing up topics rarely ever discussed in this community earlier, so that was really great. I enjoyed that. Especially the Mercator part. Thank you.
So going back to the map projections, we don't have an accurate map of the Earth. Nobody does. Even admittedly, the Mercator map doesn't have the continents correctly proportional. We know that a lot of these maps are Western centric. America is way bigger than it actually is compared to Africa and South America. You know that, right?
On some maps, not on all maps.
Is that what you're talking about?
No, I'm saying you're going to be hard pressed to find an accurate map that depicts all the continents to scale, accurate
That's not true.
proportions.
There is one. There's one.
There's one.
Yeah.
Yeah, what about Globe? What about that?
I don't know if it's
No,
exactly
even
accurate. When you
the
hold the
Globe-
string,
no,
yeah, when
hold
you
on.
hold a string across it, it's not exactly accurate.
Real quick,
Why
even
would
the
you use a
globe,
string
hold
model?
on,
Use a computer model.
even the globe, though it averages out the proportions, it's not to scale. Like you actually, you know, the local maps, the topographical local maps are more accurate than the globe projection.
Well,
No,
yeah,
you're right.
Globe.
Why would you use a computer model? Why would you right? You could just do it mathematically.
Well, yeah, and a globe projection, yeah, but just a globe, not a projection, just a globe.
Yeah, just a
No,
globe.
that doesn't.
Just
Yeah,
use a
if
computer
you
model.
just take a globe, yeah, if you take a perfectly spherical globe like the ones you could buy at the store or whatever, and then
Oh,
you
computer
take the side.
generation.
What?
A computer
Why
generation.
are you talking in the middle of me talking?
Because you're just lying about what we're talking about. Why don't you just use a computer generation? Why don't you generate?
Shubil literally
Wait,
just
just go
said.
on mute and wait
You're
until
not
he
going to keep
finishes.
doing this, dude.
Shubil literally just said just a globe. So I'm assuming he's talking about one that I can go pick up, purchase in physical reality. Am I incorrect, Shubil?
Yeah, you can generate it by computer.
I am
as well.
incorrect. Okay, I'm sorry. I
Yeah,
thought
no,
you were
yeah,
talking about a
you can.
physical.
No, you can go and get a proper globe. Not, your dime store ones are, a little bit sketchy, but there are proper, accurate globes, and
Yeah,
you're not
like
going
the
to find.
granite, the big old granite one, that they sell.
No,
They have it.
not even big old granite ones.
Okay, well, whatever. You take a string and you make it. You go across Australia, you go across Africa, you go across America, and you're gonna find discrepancies in that
Nope.
map.
Only discrepancies will be just minor measurement thing, not getting the string straight, whatever. The globe gets it right. There's nothing it doesn't get right.
No, the local maps are more accurate. I know it's hard to believe, but the local maps are more accurate. Navigators use local maps, dude. They don't use a globe projection when they fly around. Dude.
Yeah. Do you guys agree you don't live? Do you guys agree
maps.
you? Hold on, John. You don't live on a perfect sphere. The globe you go by is a perfect sphere. It cannot be
Well, it
accurate.
isn't.
Doesn't matter.
Sorry.
Doesn't matter.
Doesn't
Supposed to
matter.
solves all your problem.
Yeah, and
Well,
just to be clear,
the imperfection of the sphere isn't even 1%.
It's undetectable. Yeah.
yeah, and also the perfect sphere that you think a globe is that you go out and buy, it's not a perfect sphere. That's just incorrect. And this is why you'd use computer-generated like globes. It'd be a lot better, right? Because then you can be more precise. And we just don't want to acknowledge that's a thing. I get it. Though.
Bellerby globes are a little bit pricey, and they are academic grade, and they are, you can get 1 to 40 million scale, you can get 1 to 20 million scale. And yeah, you're not going to find issue with that. If you take a fine wire to measure great circles, you will not have an issue beyond 1%.
Yeah, all of that is all of that is mapped off the coordinate system, correct? The celestial sphere.
It's mapped on the coordinates of the Earth. It's
Yeah.
Okay,
mapped on the
and
coordinates of the Earth.
are those taken from GPs of stars? Those
Not
coordinates?
necessarily.
No, they're not.
Not necessarily.
Okay, so if I'm at 45 degrees latitude, how do I know I'm at 45 degrees latitude?
Well, it depends on
Well,
where
it's
you
just
start.
saying, yeah, right?
Yeah, where is the latitude line? Is it drawn on the Earth, or where is it?
Well, there's a lot of things you can do. You can just start at one point and then measure how far you're moving, right, in space. It's not difficult.
And where was the original latitude line I started from? How do I know that?
Say you can start from any landmark.
A landmark. And how did they decide where the landmark would be, and how did they know which latitude it would be on?
Is there an issue with using?
Start at any point.
No, it's not an issue, Shubil. It's not an issue.
No. Okay, then let me ask a question then. I just want to ask a question. I want to ask a question. Is there an issue with using the best available technology, which may in fact be stars, to be the most accurate? Is there an issue with that?
The only issue that I could find is the celestial sphere being apparent in the sense that those stars aren't actually equidistant from you, right? So it looks that way to you, but it could be actually not that way. You know what I mean? Just because it looks that way doesn't mean it is that way. And then yes, you can come to the conclusion that when you look at those stars and map it on the ground, you can say, you know what? When we do this, we're in an infinite looping coordinate system here. So we're going to make it a sphere. And that's perfectly fine and acceptable, and I understand why you would do that. The next battle you would have to do at this point is measure the curvature, which, Shubil, I know that you claim to have measured the curvature of the Earth. No doubt. I get that.
We're jumping from a lot of topics. You want to talk about the stars? Do we want to talk about the stars, or are we going to avoid the stars?
No, I was explaining the point. Do you agree, though, that it's possible that what you observe and what it looks like doesn't mean that is the case of what it is, right?
That doesn't mean anything because we're super vague. So unless you're more specific, I can't agree to that.
One at a time. Yeah, one at a time. I want to say something about that. Using the stars to map the ground. You're not like using the stars and mapping the stars' position. You're mapping your position on the ground, and it's fine to be able to use the stars for that. But it doesn't mean that you're mapping the ground according to the stars. You're just using
Okay,
them as
how
a
did you
tool.
determine you're on a sphere and not an infinitely looping planar surface?
So there's something called celestial,
like a manifold.
celestial rotations, all of those things.
Yeah, sunrise, sunset, eclipses, and tides. Yeah, we determined shape before we even made any measurement.
So the sun to you is taking a curved path?
No.
Because that's not the case. It's the Earth rotating and the Earth is curved, right?
Yes.
Yeah. So that's what I'm saying. So yeah, we can mark all these positions, but you understand that would be the same exact concept if it was infinitely looping on the Earth, right?
I have no idea what the infinite looping means.
What the hell does that mean?
He's been talking to Arwen, is what he's been doing.
It's unfalsifiable, dude, and I believe the truth would be unfalsifiable. And I believe the globe can be falsified because of the strictness of the measurements of the globe.
You got your work cut out for you.
Okay, yeah, good luck with that one. What the hell do you think it means to say that if the Earth was infinitely looping? You think there was just some portal on one side and then you walk through it and then you go back to the other side?
You wouldn't even know. Yeah, you wouldn't even know it. And this is why they would call Japan the land of the rising sun.
You think that it's less likely that we live on a globe and more likely that there are portals on every edge of a flat Earth that you teleport to the other side when you walk past that?
Well, when you say
I want to hear you say that.
Okay, yeah, I can make the argument for it if you like.
No, which is more likely?
But we have all the mathematics for the wormholes, everything. But what I'm saying, when you say which is more likely, I look at water and I go, which is more likely? The infinite looping Earth, yeah.
Okay, so you think it's more likely that there are portals that teleport you to the beginning of a round disk instead of just Earth being a globe? You think that's
instead of dark matter, time dilation,
that has
instead
nothing
of
to do
all
with
the
the
things,
globe.
because you
Nothing to do
have
with the
major
globe.
cool things in your
Nothing to
model
do with
too,
the
like
globe.
black holes,
Nothing to do with the
wormholes,
globe.
spooky action at a distance.
Still has
Yeah, it
nothing to do
does.
with the
Dude, if you
globe.
don't think the bending of space and time has anything to do with the globe, then you don't even know the globe.
Okay, so you think that gravity existing and the Earth being globe shaped have to be
No, it's fantastical.
Intrinsically,
it's
I thought we
fantastical.
were interrupting each other. Okay.
Yeah, I don't care. It's fantastical, the idea of what you're talking about, just as fantastical as this idea. They're both fantastical. You're correct. They are both requiring magic.
Yeah, I didn't say that. So I like that you admitted though that your position requires magic, but it's very.
So does yours. It's called dark matter and dark energy.
How about one point at a time?
So again,
how about one point at a time? One point at a time. Can you describe what causes a sunset? How can a flat Earth and the sun disappear?
The portals, the wormholes. You just said that. That's
The
why
sun,
Japan
just
is
the same way driving past a light. Just the same way as like a traffic light. It arcs over your head. As you approach it, it goes above you and then it goes back behind you.
But you can zoom in traffic lights though. If you're in a hallway of a hotel and you walk to the end of that hallway, you can use binoculars to see the light.
That's not analogous.
Oh, I'm so sorry. I thought we were going to interrupt each other. So you can actually zoom. Yeah, I know you don't care because it destroys your point. You can actually zoom in the light back in. You can actually see that. But there's nothing that you could do to make a sunset go back over the horizon.
Go 100 miles away from the light.
Go 100
miles.
There's absolutely nothing you can do to make a sunset go above the horizon. But if things were a flat plane, there's absolutely no reason that you wouldn't be able to zoom a sunset back over the horizon. But you can't.
The sun is always above. No, I need to respond to that. The sun is always above the plane in the first place. And if you went 100 miles away from that traffic light, you're not zooming it back in. So I don't know what you're talking about.
And how come the Burj Khalifa example
exists? This entire globe. If it was a flat plane, you would zoom it back in though, right?
I've got a question.
Why would you not if it was a flat plane? Why would you not be able to?
Because you know that when you have a medium like glass and you stack glass upon glass upon glass upon glass, it gets harder to see through.
Yeah, but that's not what we're talking about. I'm saying if things were a flat plane. Yeah, sure. So
you're saying the atmosphere is not a medium?
Yes. Yeah, so when you see a sunset, when a sunset occurs, unless you're arguing the atmosphere stopped you from seeing a sunset and it's not the distance, now you're talking about two different things. No matter what the atmosphere is, if you see the sunset, you see the sun. So there's no reason the sun going below the horizon means more atmosphere would cloud you seeing the sun. You just saw the sunset.
For sure, you would expect sinking refraction at those distances, for sure.
To add on to Turkan, we also have the Burj Khalifa example.
Yeah, there's also that as you rise up on the Burj Khalifa. Oh, do we want to talk about triangles again? Do we want to do that?
As you rise up on the Burj Khalifa, what happens? You can see the sun again, right?
Yeah, that doesn't make sense on a flat Earth because the longest side of a triangle.
It most certainly does. It opens up the angle.
I'll literally explain it again. The longest side of a triangle, if the Earth was flat, the longest side of a triangle is a hypotenuse. As you rise up on that triangle, as you rise up on the leg, right, on the y-axis, that distance between you and the sunset is now further than when you were on the ground. That doesn't make sense. So if your argument is there's things in between you and the sun, then even less so should you be able to see the sunset as you rise up on a flat Earth. You won't acknowledge this fact either.
Is the atmosphere more turbulent towards the ground or above?
It doesn't make a difference. Your whole entire argument was that the sun is
answer the question?
I'm literally explaining why it doesn't make a difference in your own view. You yourself just said the fact that the sun is either further away or there's stuff in between you.
You're saying on a flat baseline. You're saying if something. You're saying on a flat baseline, if you go up higher, you shouldn't be able to see further unless you're only on a curved surface.
I'm saying if the Earth was flat, the longest side of a triangle is a hypotenuse. If you think it's either distance or things in between you, it wouldn't make a difference in your view because you're both further away and there would be more stuff in between you.
Yes, it does. It makes a huge difference. The viewing angle.
It's the angle you're viewing.
So do we want to talk about how triangles work? We can go back to like
the hypotenuse gets longer. I understand the hypotenuse gets longer, but either way, your vantage point is increasing, right? Your angle to the object is increasing from an acute to a more obtuse angle. That allows you to see more of the object.
That's not how triangles work.
It goes acute to less acute. Yeah, the angle would get less acute as you raise higher.
Not obtuse necessarily, but less acute.
Angle would get less acute.
You observer
hypotenuse
to
isn't an
the
angle.
thing. No, the observer to the object. Okay, so you have
That's
the
a line, not an
baseline
angle.
and then the object, right? You have the baseline and then the object you're looking at. That's the point, and now you have a hypotenuse going back up to the observer's eyes, right? So
your
now,
hypotenuse starts to get longer, which means
yeah.
both
Wait, hold
distance
on.
and there's
But
both
once you
distance and
hold on,
there's
dude.
more
Once
stuff
you
in
go
between you.
up higher, I agree. The hypotenuse gets longer. I'm fine with that. But also the angle gets less acute, which incurs
angle?
like the angle where the object is, where the hypotenuse meets the baseline.
It's literally
but
called
that's
the
not where
viewing
you're.
angle.
Yeah, but that's not where you're seeing things from.
What are you talking about? I'm saying that's the triangle you would draw, and that angle would widen. That angle would widen as you got up
But that's
higher
not where
on
you're
that
seeing things
triangle.
from. Where you're seeing things from is you're seeing it from the top of the hypotenuse. You're not seeing it from the base angle.
No, and then when you go up higher, that base angle is going to get less
You don't see it
acute.
from there.
As you go higher on the triangle, you're the vertical part of the triangle, the 90-degree angle, right? And as you go higher, the hypotenuse, of course, is going to get longer, but the angle is going to get less acute. Do you agree or disagree?
You don't see from there. That's not where you're looking from.
If you're going up higher, you would see from there.
No, but the angle that's getting wider isn't the angle you're looking from.
Dude, you're being like retarded right now. Either way, it's the angle.
Those angles would
Hold on, bro.
increase.
There's three. Hold on, there's three angles in a triangle, right? You got the
No, it
angle
would
at the
actually go high
base.
enough if
You got the 90-degree angle at the base, right? You got the 90-degree angle at the base, the right triangle, and then you got the two other angles. I forget the exact technical names in geometry, but you got the angle that's up at the object that you're viewing, and then as the observer is rising in elevation, you got the other angle at the top of the triangle. Both those angles start to increase and become less acute. Both the one at the object and the one at the observer.
That one will decrease.
So
Yeah,
basically, both angles. Hold on, real quick. Both angles that are connected to the hypotenuse are increasing.
No, one would be decreasing. The one going up on the right angle leg would decrease. Yeah,
The one you're looking from.
but what you're trying to see would be increasing.
No,
and then that
what you're trying to see would be increasing. The thing is, it changes size.
No, where the object is where the other point of the hypotenuse is, and as you go up higher, your angle decreases. That angle necessarily has to increase, correct?
Yeah, the other angle, but that's what you're looking from.
What are you talking about? What does that matter? Can you give me the reasoning behind that's not where you're looking from?
The whole point is it doesn't matter. That's what I'm saying. So I don't know why you keep bringing it up. That thing.
You're saying that if you go higher up, and you can see further, the only explanation for that is because the surface is curved.
I'm not saying that's the only explanation. I'm just saying on a flat Earth, this makes no sense because both their distance and the stuff in between you, both their distance and the stuff in between you is going to be increasing. So for both your explanations, it doesn't work.
I just did the triangle thing for flat Earth, and both angles are supposed, according to flat Earth, both angles should increase. However, that's not how a triangle works.
That can't be possible. Yeah, of course not. No, we understand that. If you have a 90-degree angle and then the angle to what you're looking for increases, obviously the angle that you're looking from is decreasing. Yeah, I agree with that. No problem. That's perfectly fine. But once you open up that angle, you're able to see more, and you can see further because the hypotenuse is longer. So obviously you can see further.
No, you can't see further. Literally, if you think your eyesight is limited because of the stuff in between you and or the distance, both of those things increase as you go up on a flat Earth.
Yeah, I'm not saying that's the only thing. I didn't say the only thing that's causing that is the atmosphere. There is also the angle to the object.
Why would that stop you? Why would that stop you from
Why would
seeing
what stop you? If you go up
Why
higher,
would
the
the
sun
angle
doesn't
stop
set.
you?
My question to you is, how high do I have to go until the sun doesn't set at all anymore?
You would have to. I mean, it depends.
On a
When you mean
sphere.
high, you
On a
mean-
sphere.
Well, it would. I mean, at some point, you're just gonna have an eclipse of the sun from the Earth, right? Depending on where you're disappearing.
Okay, can you prove that?
Yeah. So if you imagine a light and then you put a ball in front of the light, it's just gonna eclipse it's a thing. It's called a lunar eclipse.
Okay, yeah, no problem. So that's your explanation. So
Well, it
how
would
high?
be-
If I go below the equator, right, and I'm gonna go 15 degrees below the equator, and then I want to go and I want to see Polaris. How high up do I have to go?
I don't even know what you're asking right now. The whole point of this is just saying on a flat Earth, if you think the reason you can't see the sun, the cause of sunsets is either distance or stuff in between you, aka the atmosphere, on a flat Earth, as you go up, both of those things increase.
Think about it like this. You can, even in a globe, you can have a plateau, right? Where you have a flat surface on a globe. Can we agree with that? You know what a
I
plateau
want
is?
you to respond to what I just said about both your
Or
distance
valley.
and the stuff in between.
Yeah, I don't think
you.
I disagree. I disagree with your premise
example, dude.
that they
Okay,
both
why do you
increase.
disagree? Yeah, why do you disagree?
I don't
We
believe
both
they
agree the
both
distance-
increase.
Okay, so we
Jesus
both agree
Christ,
the
dude.
distance increases, right? We both agree with that. The distance increases, right?
The distance to the object.
Yeah. So if you want to say it's the stuff in between you, now you get really wonky the second you start to go to the southern hemisphere as sunlight increases or you get less sunsets the further south you go. Now this is why you have to pretend the southern hemisphere doesn't exist and you can actually record the 24-hour sun in the southern hemisphere. But if you're going to say it's the atmosphere is the cause of it, now you're just going to have to lie about the southern hemisphere. But we can do that if you want.
No, that's from coming from the position of like an AE map or something.
Sure. So I want to hear you try to explain sunsets in the southern hemisphere using the fact of atmosphere.
The sun never goes below the horizon. The sun is always up in the sky. So when it's
I'm
setting
asking
for
what
me,
you
it
think
is still
sunsets are. What do you think?
I think they're
on sunsets?
exactly what they are. It's an apparent effect of the sun setting.
Yeah, caused by what? What's it caused by?
There's many things. It's caused by
Yeah,
your
there you go.
angle to the object. There's the atmosphere in between you. There's a bunch of
What
different
else?
things.
Anything else?
Yeah, I would say there's like with the humidity in the air as well.
You have effects that could cause sinking refraction, especially when you're looking at it over the ocean. Because when you watch a sunset, like at the beach over the ocean versus on top of a mountain, it's a little bit of a different experience. Don't you agree?
Yeah, but this again, it's super fucked. This if you go to the Southern Hemisphere. If you have someone in South America, South Africa, and South Australia, they're all going to see the sunset, right? They're going to be in different times. They're going to be in different temperatures. So how do you explain this? They're going to have the same angles.
What are you saying? What do you mean? How do I explain what? That the sun sets?
Yeah, you think that sunsets are caused by temperature, right? Humidity. You think it's caused, or sorry, you said humidity, you said atmospheric conditions, and then you said basically the angle of observation.
Yeah, like Rayleigh's criterion. Yeah.
Yeah. Okay. So you get really fucked as soon as you start going down to the southern hemisphere because all of these things on a globe all line up perfectly, but then you have a bunch of different things causing the same sunset in the southern hemisphere, right? So you can't get this to line up.
Like what? Can you just explain it? Can you explain it further? Like what?
Sure. So do we agree that we would say South Australia, South Africa, and then South America have different weather conditions?
I have no idea. I've never been there. I don't even know if they exist.
Okay. So you just have to lie about these things. Yeah.
No, it would be a belief of mine, if anything, that I could say they have different weather patterns. I have no idea. I don't have actual empirical knowledge of it. I don't have like actual I've never put hands on down there.
Do you think South Africa, South America, and South Australia exist?
I'm told they do. Yeah.
Do you think they do?
Yeah, I think they do. Yeah, I'm just not. I just couldn't tell you for sure 100%.
Do you think sunsets occur there?
I'd imagine. Yeah, I definitely imagine. People say they do.
Yeah, but do you think they do?
Yeah.
Okay, so you think
I believe they do, right? I believe they do.
Yeah. And do you believe that they have different weather conditions while they're having sunsets?
Not necessarily. No.
Okay. What about like the South Pole? Do you think it's different weather conditions in South Australia, South America, and South Africa? Do you think the weather conditions are different for the South Pole? And do you think you could go to the South Pole? Do you think that's a thing?
Yeah, it seems to be. I don't know if it's an actual like point or anything, but yeah, you can go below. Like you could go to 90 degrees or whatever.
So do you think people like have jobs at the South Pole, or there was a recording of the South Pole, the 24-hour sun in the South Pole?
Yeah, I believe that. Yeah.
Yeah. And how do you explain that 24-hour sun in the South Pole?
Well, we all see the sun in an apparent location. We don't know where it physically is, and the way that it spreads its light, in my opinion, is a mystery to man. So then, if we live on an infinitely looping map that looks like a Mercator, you would still have the possibility of seeing the sun for 24 hours, no problem.
Yeah, but what match would the continents and countries see?
Yes.
Yeah.
That's what day and night or date and time uses a Mercator map. Yeah, and it matches.
I'm talking about date and time. We're talking about the sunset and how light appears actually on the Earth as people experience day and night, like the literal.
That's what date and time does. Yeah, that's literally what date and time does.
No, it's not, because there are places, because for some reason China wanted to have their entire country in the same time zone. So some places in China are within the same hour, but some places are day and some places are night. So that's just not true. I'm talking about the actual sunlight.
That's what I'm talking about.
They have universal standard time.
Yeah, that's not the same thing.
Greenwich time.
Yeah. Just go to timeanddate.com and tell me what map they're using.
Yeah, I'm not talking about time zones. What I'm talking about is the actual.
I'm not talking about time zones either. I'm talking about literal timeanddate.com, which shows you what portions of the Earth is lit up and what portions are in darkness. That's literally what time and date does.
So
and it's not a globe.
The light.
It's on a Mercator map.
So I'm talking about the literal light that hits the surface of the globe, right?
That's what I'm talking about.
Okay, I get it. So you want to try to explain this somehow, which I still haven't heard.
No, I can't explain it. I said it's still a mystery to man. Yeah, it's a mystery to man.
Saying it's a mystery is you can't explain it.
Yeah, you're correct. I do not have a explanation for how the light or how the sun delivers its light and where it spreads to on the Earth. You're correct about that.
Okay. Do you know where the light hits the Earth at any given point?
Yeah. You could go to timeanddate.com and see.
No. But I just said that you could look up if the Earth is a globe, right? You could do that. So citations to the internet?
Yeah, no doubt. I already conceded that if it is an infinitely looping Mercator, you would imagine it as a globe.
You're making a citation to the internet, so I can also make a citation to the internet, right?
I don't see the relevance into this conversation.
Okay, so we can or can't make citations to the internet.
Yeah, we most certainly. I'm just telling you, when you asked me for where is it lit up on the Earth, I gave you timeanddate.com to show you accurately where it is lit up on the Earth, and it's on a Mercator map. So if that is infinitely looping, I could see you conceiving of a sphere.
I'm saying you just made a citation to the internet. I would like to make.
Do you have any measurements of longitude lines converging?
No, I'm asking. Is it okay to make citations to the internet? Because we can make a bunch of citations to the internet. Do we want to do that?
Typically, you'll pull citations from the internet. Yeah. I don't know why you're stuck on this point.
I'm just curious. I want to hear you say it's okay that we could just look.
I already did, dude.
Dude, what's going on? You guys are jumping around so much, bro. It's crazy. Like, can we stick to one thing?
Together. Do we want to look up if the Earth is a globe?
Can we vote on a topic change? What do you guys say?
Let's change the topic.
I don't want to be alone. I don't want to be accused. What do you guys say?
Let's change the topic.
I think it's exhausted. Yeah, I think the topic has been exhausted.
I agree.